Hello guys, welcome back. In this video, we'll see another question from GATE EC 2020 based on network theory. So this is a two-port network kind of question, okay? So in the given circuit, the two-port network has the impedance matrix Z equal to 40, 60, 60, 120. The value of ZL for which maximum power is transferred through the load is dash ohms. So if you remember properly, this is nothing but your maximum power transfer theorem kind of question. And we already solved this similar type of question, if I am not wrong, for an admittance parameters. So now they have given impedance parameter. So for maximum power transfer, we already saw that first thing we have to do is we have to convert this part of the circuit into something like VTH and RTH. And for maximum power transfer, your ZL max power transfer will be equal to this RTH, right? So you needn't even find this VTH. It's only enough if you find the RTH. So let's go ahead and find the RTH of this network. So to find RTH, the first step you have to do is you have to short your voltage sources and open your current sources. Here there is no current source, so you only need to short this. So now from the Z parameter, what can you write? So you have your V1, V2 related by your Z parameter matrix related to your I1, I2. And what is your Z parameter? 40, 60, 60, 120. So 40, 60, 60, 120. This, if you write it, you will get 40 I1 plus 60 I2. And your V2 is 60 I1 plus 120 I2. Right? Okay. So now what the other thing we get? Anyway, here we have to open circuit, right? We are wanting to find this impedance, RTH. Okay. So similarly, what we can do is I'll choose some voltage source here of value, let's say 1 volt, and I'll find I2. Okay. And then my RTH is nothing but 1 by I2, right? Or I can also put a current source and then I'll find V2 where my RTH will be V2. Any method is fine. So here once I put a voltage source, my V2 becomes 1 volt. On the other hand, what is the other equation you have? Your I1 is nothing but V1 by 10. Is it minus V1 or plus V1? So here it is minus V1. Why? Because your current is going from minus terminal to plus terminal of the voltage across the resistor. So your I1 is equal to minus V1 by 10. So if you are in doubt, what you have to do is you can just take this node as ground, then this voltage will be V1. So current in this direction will be V1 by 10. Your I1 is in opposite direction, so it will be minus V1 by 10. Okay, so now using these, we can substitute it here. Then what I will get? I need to finally find I2, right? So I'll put I1 in this equation. Or is it better to put V1 in this equation? Because I need to eliminate I1 from the second equation. So I'll find the relation between I1 and I2 from the first equation. So my V1 is minus 10 I1. So minus 10 I1 is equal to 40 I1 plus 60 I2. So minus 50 I1 is equal to 60 I2. My I1 is equal to minus 6 by 5 I2. Okay. Now V2 is 1 for me. 1 is equal to 60 I1 plus 120 I2. And I1 I can substitute 60 into minus 6 by 5 I2 plus 120 I2 equal to 1. And here what I have, this will be 12 times, and 12 into minus 6 is minus 72. I2 plus 120 I2 is equal to 1, and 1 is equal to, this is 48 I2. So my I2 is equal to 1 by 48. I want 1 by I2. My RTH is 1 by I2, which is 48 ohms. And my RL or ZL for max power transfer is equal to 1 RTH, right? Which is nothing but 48 ohms. So this is your answer.